good in this lockdown days. And anyhow, you all watching my concept videos, I hope. If you are not watching, kindly watch the videos and learn something. If we're going to start our videos, let's have a word of prayer. Let's close our eyes. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Let's move on to the exercise number 1.3, problem number 1. Alright, let's start first question. Right, let's move on to the first question. Determine whether or not each of the definition of star given below gives a binary operation. In the event that star is not a binary operation, give justification for this. So what they said here they given some 5 problems in your first question, and each one we need to check whether it is a binary operation or not. If it is binary operation, why it is binary operation? If it is not binary operation, why it is not a binary operation? You need to give justification for that. So now first we are going to discuss in that out of 5 first one, that is a star b is equal to a on n. So we need to check whether it is a binary operation or not. Here I'll write here it is star is a solution for this. Star is a binary operation. By observing itself we can say it is a binary operation. Why? Let me check. Okay, so it is all natural numbers one, so let me check the natural numbers one. Okay, so here y means a star b is equal to a. Here a, this whole belongs to the natural number. Because of that reason we can say here it is star is a binary operation. Since the reason behind here it is a comma b is also belongs to natural number, and whichever you get that number, a is also a natural number. So directly we can say it is, therefore star is a binary operation. Star is a binary operation. For your understanding purpose, I will take one example, then I will explain. So let's take a is equal to one natural number, b is equal to 2, one more natural number. So then when I do this, I need to get a natural number again. So let me check now one and some operation. Let me do here. It is a as I will take as 2 and b as I will take as 1. It is possible or not? Let me check. So let me take a minus b, that star number. So 2 minus 1 is equal to 1. So a minus b is equal to a. So here it is b, and still some more examples will take. So means here mainly what is here it is, this should be a natural number. So here whichever it is, you got here a natural number. So because of that reason it is a binary operation. So what is binary operation? Why it is binary operation means here a and b is belongs to natural number, so whatever the result also it belongs to the natural number. So that is about your first one. So it is a binary operation because whatever the numbers a and b, if you do, you need to get one natural number. It is not exactly equal to the a, means we need not to get that one and those all. Okay, if you want, this will be possible for multiplication. So for subtraction not happen, let me check the multiplication. A is equal to 2, b is equal to 1. So multiply now. So 2 into 1, what you get? 2. So now here a and star place it is, that will be the multiplication. So that into b. So a star b is equal to what you got answer? A. So it is possible. That's the reason we are saying it is a binary operation, and it is belongs to the natural number. This is about your first one. Let's move on to the second. Right, let's move on to the next. So that is second one. A star b is equal to a plus b minus 3 on n they given. So then what we need to do here, it is here again it is on n. So only natural numbers you have to take, and when you take natural numbers, your result also you have to get a natural number. Then only this binary operation is possible. Let's start and check this. Here star A star B means what do you know? A plus B minus 3. So let A is equal to 1, B is equal to 2. Then what will happen? Here 1 comma 2 belongs to the natural numbers. Now A star B is equal to, what do you know? A plus B minus 3. Now A is nothing but here 1 plus B is nothing but 2 minus 3. 1 plus 2, 3. 3 minus 3, what you get? 0. And this 0 is not belongs to the natural number. So you all observe here carefully. A is equal to 1, B is equal to 2, and then 1 comma 2 is belongs to natural numbers. A star B means what do you know? A plus B minus 3. So A is take as 1, B is take as 2, then 1 plus 2, 3, 3 minus 3 is equal to 0. 0 is not belongs to the natural number. When you are not getting a natural number, can we say it is a binary operation? No. So therefore what we can write here, therefore it is not a, it is means here, it plus you can write star is not a binary operation on n. So in this natural number, for this statement, it is not at all possible this binary operation. That is about your second one. Let's move on to the third. Alright, third one is this: A star B is equal to A plus 3B on n they given. So then by observing itself we can understand that the first whichever numbers we are going to take in natural 1 and 2. Just to substitute 1 and 2 here. 1, 3, 2 is 6. 6 plus 1, 7. 7 is always, it is belongs to the natural number. So definitely it is going to be a binary operation. So directly write here star is a binary operation. So if you are observing that immediately, if you write binary operation, it's okay, but still what they said, give justification why it is a binary operation. So let me take 1 belongs to n and 2 belongs to n. So here A is equal to 1, B is equal to 2 take. Then what is possible? A star B is equal to, so you can write as A means what is? A plus 3B you know. So A means here 1, 1 plus 3 into B is nothing but 2. 1 plus 3 2s are 6, that is nothing but 7, and this is belongs to the natural number. So therefore this star is a binary operation. Otherwise it is not going to be a binary operation. So you all understood now here. See here, two natural numbers we took and substituted. We got again natural number. That's the reason this equation is possible and it is a binary operation. So this is about your third one. Let's move. I hope so you are understood. Let's move on to the fourth. Right, let's move on to the fourth. Here A star B is equal to A upon B on Q given. So now by observing itself you can able to say that A upon B, they said you know that 22 upon 7 is nothing but what do you know? It is not at all belongs to the Q. It is not, it is a special case. It is a irrational number. Except those all remaining all, we can say that it is possible this operation. But now this star is binary operation possible means yes, obviously it is not. So we can write here star is not a binary operation. So what is the reason here? So why it is not a binary operation? Reason why it is not a binary operation. Let me take 22, that is equal to A, belongs to natural number, and 7 is equal to B, that is belongs to the natural. So it is not natural number. So it should be which number? Q means rational number. So it is belongs to the Q. This is also belongs to the Q. So now what I can do here? So here it is A star B is equal to A upon B. So A upon B means A is here 22, B is here upon 7. 22 upon 7 is not belongs to the Q. So therefore star is not a binary operation on Q. Star is not a binary operation in Q. So this is about your fourth question. See, very simply is there all the questions. Let's move on to the last and final question in this first question. Alright, let's move on to this fifth problem. A star B is equal to A minus B on R they given. By observing itself, you can understand that A you take any number, B you take any number. When you subtract, always you are going to get a real number. So directly we can write star is a binary operation on R. So the reason behind this, so you can observe here. So here A is belongs to R, B is also belongs to R, and A minus B also belongs to the R. Then example, let me take one example here. Let me take A is equal to 7, B is equal to 5. Let me take. So this belongs to R, this is also belongs to R. Then what is here? A minus B. A star B is equal to A minus B. A minus B means what do you know? 7 minus 5. That is nothing but 2. 2 is belongs to the R. So because of this reason, it becomes as a binary operation on R. So this is about your 5 problems of your first problem in this binary operations exercise number. It is your exercise number 1.3. Okay, so this is about your first one, and let's move on to the second. All right, let's move on to the second question. Determine which of the following binary operation is commutative and which is associative. In that 5 problems is there, like your first problem manner. Now first problem, star on n. Star on n defined as A star B is equal to 2 power AB. Then we need to prove whether it is a binary operation or not. So how to prove it is binary operation or not? So let's think first. A is belongs to n. So here let A is belongs to n, B is belongs to n. So then you know that for commutativity what we need to do. So here I am writing commutativity. So the first for commutativity, you already know that A star B is equal to B star A. I need to prove this, then we can say this commutativity is possible. So let me take now LHS, that is A star B. So you know that A star B means what is the given here? 2 power AB. So write that 2 power AB. Can I write this 2 power AB as 2 power BA? Just what I was done first, I was changed the order. So however order changed, we get AB or BA, both are same. So that's what now 2 power BA is there. B came first means what is that? B star A. So now write it is B star A, that is equal to your RHS. So now here A star B is equal to B star A happened. So from this, therefore A star B is equal to B star A. So it is means here star is commutative. Okay, so this is about your first one, and still it is what we need to check. We need to check for associative also. Let's check the associative. So here associative, let me check. So now associativity. So let me write here associativity. So associativity, how to find now? So same method. Let A is belongs to N, comma B is belongs to N, comma C is belongs to N. So let me think A, B, C all belongs to the N. And now first let me think about A star, A star, B star, A star, B star C is equal to A star to B C. So B star C means A star B means 2 power AB, B star C means 2 power BC. Now this becomes as A and this becomes as your B. Then now A star B means what you are going to get. So if it is A star B, then we can write it as 2 power, we can write it as this 2 power A into 2 power BC. So now it is 2 power A into 2 power BC. Give us equation number 1. So now let's move on to the second part here. When you go to the second part, that is A star, A star B star C. A star B means what do you know? 2 power AB star C. So 2 power AB star C is nothing but what we can write, 2 power 2AB. So 2 power AB into C. So this becomes as A and this becomes as B. So A star B, that is 2 power. So A is here 2 power B into B is here C. So this is equation number 2. So now from 1 and 2 what we can say? From 1 and 2 we can say star is not associative. Star is not associative. If star is not associative, then what we can say about this, that is star on N defined as A star B is equal to 2 power AB is, it is commutative but not associative. This is about your first one. Let's move on to the second one. Defined as A star B is equal to A plus B plus A square B. So here again first one what we need to check for commutativity. So for commutativity, another one it is associativity. So commutativity means what we need to do here. So this star is belongs to N, this side A is belongs to N, B is belongs to the N. So and now first A star B is equal to, what can I write? A plus B plus A square B. And now B star A, let me check. So this give equation number 1. B star A means A plus B, B plus A, and then A square means here B square, and B means here A. This equation number 2. You are observed here A okay, B okay, but here A square B, here B square A. These both are not equal. So from 1 and 2, A star B is not equal to B star A. So therefore, star is not commutative on N. Okay, let me go for now associativity. So associativity means what we'll take first A star B, star C. So A star B means what do you know? A plus B plus A square B. Then star C. Another one A star, B star, C. So A and then star B star C means B plus C plus B square C. By observing here itself, we are able to find out that this is not a binary operation. The reason behind that, here you are finding that A square B, here you are finding B square C. When you multiply also, you could not get at any cost this answer, because here B square C you may get, so that is A B square C. Here you may get A square B C, so that these both are not at all equal. So now we can write here equation 1, equation 2 from 1 and 2. So A star B star C is equal to A star B star C. We can say equal to, no, it is not equal. So therefore star is not associative on N. So at last statement, therefore star is neither commutative nor associative on N. So this is about your second one. So commutativity we have said, and associativity also we found. It's very simple one. If you have any doubts, you can ask me or comment in the YouTube or send me message so that I can help you all. So this is about your second. Let's move on to the third. Let's move on to the next, this third one. In this third one, star on Z divided as A star B is equal to A minus B. Fourth one is star on Q. This is Q defined as A star B is equal to AB plus 1. Let me check for first one. It is commutativity here. Commutativity. And here it is associativity. So let me check. Commutativity means what we'll do here. A star B is equal to what is the given? A minus B. So now B star A is nothing but B minus A. This give equation 1, equation 2. From 1 and 2, you can write as A star B is not equal to the B star A. Therefore, it is means here star is not commutative. So next what we'll do here, associativity next. So now A star B star C, but what do you know? A star B means A minus B star C. Now these two operations, first A, this full as A and this full as B. So A star B means A minus B. So A means here A minus B. Then next B means here minus B. So that minus B plus what is here? C, minus C. So A minus B minus C. Give us equation number 1. Then next A star B star C. So A star as it is, B star C means we can write it as B minus C, because A star B is nothing but A minus B. B star C is nothing but B minus C. And this becomes as A and this becomes as B. Now again A star B. So now A minus B is nothing but B minus C. When you write it, A minus B, minus into minus plus C. So now this give equation number 2. So from 1 and 2, what we can say? A star B star C is not equal to A star B star C. So therefore star is not neither commutative nor associative. So this is about your third, and let's move on to the fourth. Star on Q defined as A star B is equal to AB plus 1. Let me check now again your commutativity. So now first A star B, AB plus 1, then B star A, again this also becomes as BA plus 1, that 1 and 2. AB or BA both are equal, so that 1 and 2 means both are same. So from 1 and 2, so here I write from 1 and 2, A star B is equal to B star A. Therefore, star is commutative on Q. Here note, remember that here it is only possible that the binary operation is possible for addition and multiplication, not for subtraction and division. Okay, let's move on to the associativity. So now associativity. So if you go for associativity, so first one A star B star C. What is A star B? AB plus 1. Then star C. So now this full becomes A and this full becomes B. So then, so A star B means AB plus 1. A means what do you know? AB plus 1 into B means what is here? C. Then plus 1. So now ABC plus C plus 1. Just multiply. Give equation number 1. And now next one, A star B star C. So A means as it is A star B star C. First complete this. A star B means AB plus 1. B star C means BC plus 1. Same method, now this becomes A and this becomes B. Then again A star B means AB plus 1. So AB plus 1 means A into BC plus 1 plus 1. So now ABC plus A plus 1. So now check carefully, ABC plus C plus 1, ABC plus A plus 1. So this is equation number 2 from 1 and 2. So here from 1 and 2, star is not associative. So at last you write as, therefore star is commutative but not associative. So that is about your third and fourth. Let's move on to the fifth. Alright, let's move on to the fifth one now. Star on or defined as A star B is equal to A plus B minus 1. How we solve this now? So let first go for commutativity. So here A and B are belongs to the R. So now first A star B is equal to, you know that, A plus B minus 7. And if it is B star A, just replace A as B, B as A. So now A as B and B as A, because changing just order. So now from 1 and 2, what we can say, commutativity is possible. So right here from 1 and 2, A star B is equal to B star A. Therefore, star is commutative. Star is commutative. So then next one, associativity. So let me check associativity. So first we'll write here A star B star C. So what is A star B? You already know that, A plus B minus 7. Star C. So this full becomes as A and this is C as B. Now A star B means A plus B minus 7. First A plus B. A is nothing but A plus B minus 7 plus B is nothing but C. A plus B done. This is A and this full is A, that is A plus B minus 7 is A, and C is a B. A plus B done. Minus 7. So write minus 7. So A plus B plus C minus 7 minus 14. Give us equation number 1. Same method now. A star B star C. So now A star B means A plus B minus 7. B star C means, so you can first I'll write A star as it is. B star C means it is B plus C minus 7. So now again this is A and this full as B. Then again A star B. A star B means A plus B minus 7. A plus B means A means A only, plus B means here B plus C minus 7. So add it, then minus 7. So now A plus B plus C minus 7 minus 14. This give equation number 2. So at last we'll write from 1 and 2, A star B star C is equal to A star B star C. It is equal. So therefore star is associative on R. After that, therefore, last step, therefore star is commutative and associative. So a star is commutative and associative. I hope so you all understood this. Let's move on to the next. Right, let's move on to the third one here. If star B an operation on Z defined as A star B is equal to A plus B plus 1 for every A comma B belongs to Z, then prove that star is commutative and associative, find its identity element, and also find inverse element of any integer in Z. So how to solve now? So it is your solution. So first it is for commutativity. So right here for commutativity, and the one associativity. Then remaining we will discuss next. So commutativity, associativity, let me check. So now in this commutativity, first A star B. So A star B means what do you know? A plus B plus 1. So then if I take B star A, just replace B as A as B. So A plus I need to write B, B plus I need to write A plus 1. Equation 1, and this is equation 2. We'll write from 1 and 2. A star B is equal to B star A. Therefore, star is commutative. Star is commutative on Z. So first one done, and associative. A star B star C. A star B means what do you know? A plus B plus 1. Star C. So this rule becomes A and this becomes as B. A star B means add all and then plus 1. So A plus B plus 1. A plus B plus. So A means here A plus B plus 1, and then B means here C. So now A plus B done, then plus 1. So when you write this part, we'll write A plus B plus C plus 2. Give equation number 1, and then A star B star C. So A star B star C means what do you know? B plus C plus 1. Because A star B means A plus B plus 1. B star C means B plus C plus 1. So then this becomes A and this rule becomes as B. Again A star B means add both A plus B plus C plus 1 plus 1 according B plus C plus 1 plus 1 is 2, equation number 2. So therefore from 1 and 2, A star B star C is equal to, we can write this equal to A star and then B star C. Therefore star is associative on Z. So this is about your associativity and commutativity. Now we need to find inverse element and that is identity. So for this we have to use our previous knowledge of definitions. Okay, let's move on to that. All right, let's move on to this. So for identity, so identity element. So if any identity element is there, so this I may think as IE. So let IE is equal to E. Then you know that what is identity function or identity element property. According to that, we can say that A star E is equal to A. So now A star B means A plus B plus 1. So now A star E means what I can write? A plus E plus 1 is equal to A. Then A get cancelled and E plus 1 is equal to 0. So why A get cancelled? A plus A go to that side minus A becomes as 0. So now plus 1 go to that side minus 1. So E is equal to minus 1. Therefore, identity element E is equal to minus 1. So this is about identity element. And now we'll go for another one, that is inverse element. So inverse element, let inverse element of A is X. Let me think that as X. Then what is property of inverse element? You already know that A star X is equal to E. E means identity element. So this is a property of inverse element or inverse of any element. So now A star X means A star B means A plus B plus 1. A star X means A plus X plus 1 is equal to E means what you found here, minus 1. So write that minus 1. So then what are the possibilities we can do now in this place? So here plus 1 go to that side minus 1. So A plus X is equal to minus 1 minus 1. Then A plus X is equal to minus 2. X is equal to A plus A, go to that side minus A. So minus 2 minus A, and X is equal to minus common, you get as 2 plus A, or we can write this as X is equal to minus of A plus 2. So this is about your inverse element of the given function. So this is about your identity element, inverse element, associative and commutative. So everything is proved, and here minus number something whichever you got, this is belongs to Z. Negative number that belongs to the Z. And because of that reason, we can say this inverse element as X is equal to minus of 2 plus A. So now identity element you got as minus 1. This is about your third problem. Let's move on to the fourth. Alright, let's move on to the fourth problem. If star be a binary operation defined on or minus in bracket 1 as A star B is equal to A plus B minus AB for every A comma B belongs to R minus 1, prove that the star is commutative, associative. Find identity element, also find inverse of A, means inverse of that element. So how to find this means you already learned same question. It was repeated actually. It is your example number 1 which was explained in your previous video. And another one, it is in your textbook if you want to check in the PDF form textbook. So in the textbook which Satish is shared for you all. So in the textbook, example number 11. So example number 11 refer as it is this only, but only one small change they done, that is in that place they written as A is not equal to 1. Here they written as or minus of 1. Here the meaning, both meanings are same only. Here also A is not equal to 1. So that as it is same answers only you are going to get. Just to confuse you, they given as or minus 1 in the flower packet. So as it is, you can already it was explained in my previous video. Just go through it and understand it. If still you are not able to understand, comment on the YouTube session so that I can reply to you all, and again I can explain to you if you want. So that is about your fourth one. This is your homework problem. So refer your example number 11, or in last video example number 1. Okay, so that is about your fourth. Let's move on to the last question of this exercise. Let's move on to the fifth. 4 functions are defined on set or circle such that f1 of x is equal to x, f2 of x is equal to minus x, f3 of x is equal to 1 upon x, f4 of x is equal to minus 1 upon x. Construct the composition of functions f1, f2, f3, f4. Means here construct the composition of functions table we have to construct. Okay. Also find the identity element inverse of every element, or we can say that what is inverse of the element. So for that, what is composition table, how we are going to prepare that. So composition table, how we do. So this we already learned previously, composition table. So that is all the functions which they are given, that for that circle. So circle is here, and then what are the functions here? f1, f2, f3, f4. Same method here, f1, f2, f3, f4. So these are the functions. This is a table. So now I need to find this composition table. If I need to find this composition table, what would I need to find? So first one, f1 circle f1, f1 circle f2, f1 circle f3, f1 circle f4. So let me check here, f1 circle f1, f1 circle f2, f1 circle f3, f1 circle f4. So I'm writing everything in one step itself, but you don't write in this way, you need to write step by step. So here f1 of f1x, and here f1 of f2x, and f1 of f3x, next f1 of f4x. So what will happen? f1 of f1x is nothing but x, f1 of f2x is nothing but minus x, f1 of f3x is nothing but 1 upon x. So next one, f1 of f4x is nothing but minus 1 upon x. So write that. And what is your f1 of x? You already know that is x. So here x is there, so that x, f1 of minus x means minus x, because wherever x is there, you need to substitute minus x. Same method, wherever x is there, you need to substitute 1 upon x. So we can write as here 1 upon x. So next, f1 of minus 1 upon x. So wherever x is there, you need to write minus 1 upon x. So now, what is this implies? So here, anyway, this equal to what is that I'll write. So now check carefully. X means what? f1 of x, right? Then minus x means f2 of x. 1 upon x, f3 of x. Minus 1 upon x, f4 of x. So from this, what you understood? f1 circle f1 is nothing but f1. f1 circle f2 is nothing but what you got here. See this and this. So this is f2. So f1 circle f3 is nothing but f3. f1 circle f4 is nothing but f4. So first one done. Can I move to next? So now I'm moving to the next. That is f2 and those. So let me check now. What is next? See, f2 circle f1, f2 circle f2, f2 circle f3, f2 circle f4. So now f2 circle f1, f2, f2, f2. Circle, 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 f2, f3, f4. Of x, of x, of x, of f2 circle. If you remove circle f2 of f1 of x, next f2 of f2 of x, next f2 of f3 of x, next f2 of f4 of x. So just substitute those values, that's it. So f2, 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 f2 of f1 of x is nothing but x, f2 of x minus x, f3 of x 1 upon x, f4 of x minus 1 upon x. So then f2 of x means what do you know? Minus x. So now here f2 of x is nothing but minus x. So that is equal to f2 of minus x means minus of minus x. That is nothing but plus x. So now that is again next f2 of 1 upon x. So now minus 1 upon x. So now f2 of minus 1 upon x. So now here minus in this and x is nothing but minus 1 upon x. So minus into minus plus 1 upon x. So now here this is minus x is nothing but f2 and this is nothing but f2, this is nothing but f3, this is nothing, so this is nothing but f4 and this is nothing but f3. See, minus 1 upon x is nothing but f4 and plus 1 upon x is nothing but f3. Just write those values, f2, f1, f4, f3. So write f2, f1, f4, f3. Same method, next one also. That is just now you need to write f3. So when you solve that, what you are going to get. So now f3, like we solve f3, 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 circle, 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 f3 circle, f1, f3 circle, f2, f3 circle, f3, f3 circle, f4. So f2, f3, f4. So then same method now, f3 of f1 of x and then f3 of f2 of x, next f3 of x, next f3 of f4 of x. So then that is equal to then f3 all the places f3 and off. So f1 of x is nothing but x, f2 of x minus x, f3 of x is nothing but 1 upon x, f3 of x, f4 of x minus 1 upon x. So now you are observed in this place here, it is nothing but right. So now what we need to do here, f3 of x. What is f3 of x? So that is 1 upon x. So that write as 1 upon x. So next one, f3 of minus x. So in the f3 of x means 1 upon x. Minus x means what you get, wherever x is there you need to keep minus x. So then you get as minus 1 upon x. Then f3 of 1 upon x. So wherever x is there, substitute 1 upon x. So 1 upon x. So denominator goes to the numerator. So you get answer as x. Then next one, here f3 of minus 1 upon x they say. So wherever x is there, what I need to do? Minus 1 upon x. So 1 upon minus 1 upon x. So you get answer as minus x. So 1 upon x is nothing but what do you know? f3 minus 1 upon x, f4 plus x, f1. f2 means minus x is nothing but f2. Just write those all. f3, f4, f1 and then f2. Okay. So next, last one, this is f4 circle f1, f4 circle f2, f4 circle f3, f4 circle f4. So here f4. So f4 circle, f1, f2, f3, f4. So now when you solve this, what you are going to get? So f4 of, so all the places it is f4. I'm like a small kid manner I'm doing this. Okay, so f4 of f1 of x. So next f2 of x, next f3 of x, next f4 of x. So when you solve this, what you are going to get? Check. So f4 of f1 of x. So f1 of x means what do you know? That is x. So write f4 of x, f4 of minus x, f4 of 1 upon x, and f4 of minus 1 upon x. So now what is f4 of x? You know that minus 1 upon x. So f4 of x minus 1 upon x. f4 of minus x means, So minus 1 upon x becomes as plus 1 upon x. So how it is means we can write here minus 1 upon x plus you need to write minus x, minus into minus plus, then 1 upon x. So next f4 of 1 upon x is there, so minus 1 upon, so 1 upon x, that is nothing but minus x. So now again here minus 1 upon x, wherever 1 upon x is there, minus 1 upon x, right? So minus 1 upon x, minus into minus plus, then you get as x. And this minus 1 upon x is nothing but f4. Another one is f3. Next minus x, f2. Next one is f1. So right here f4, f3, f2, f1. So now this is about your composition table. So after this composition table, what we need to find here, also find the identity element and inverse of every element decimal. So we need to find here identity element and inverse of every element. So here you all observing carefully here, f1 circle f1, f1 got, f2 circle f2, f1, f3 circle f3, f1, f4 circle f4, f1. So in all the places when you do that f1 circle f1, f2 circle f2, f3 circle f3, f4 circle f4, then you got as f1. Therefore we can say that f1 is a identity element. So at last we can write. So I hope so you all completed this part. Let me write here your last 2 points, okay, so that you can understand. So these 2 points you remember. So here it is, you already observed f1 circle f1, f1, f2 circle f2, f2, f3 circle f3, f3, f4 circle f4, f4. You got f1 you got. So that it is clear that f1 is identity function of f1, f2, f3 and f4. Hence inverse element is itself 2. So inverse element itself 2 for all. So that is about your total exercise number 1.3. And next class is very important class. In that class we are going to discuss our previous board examination questions, and then we will conclude this whole chapter. So that is about your composite functions, binary operations in that exercise number 1.3. So so if you have any doubts, you just comment on the YouTube so that I can reply to you as a video. So